Betelgeuse is one of the most significant sources of radio energy in the whole universe, providing more energy than 1 billion suns. If you were to place it where the Sun is, it would stretch to Jupiter's orbit, creating a monstrous, unsteady object that is about to explode. When we think of stars, we usually picture little glowing objects in the night sky, which is essentially how we see them from down here on Earth, but stars are something entirely different. In fact, one of the most prominent stars, Betelgeuse, also known as Betelgeuse, is a red supergiant star that would connect with Jupiter's orbit if placed where the Sun is. It would be utterly unpredictable and also likely to explode. For many years, scientists have been perplexed by the fact that Betelgeuse is much larger than our Sun. However, something even more concerning has been occurring with Betelgeuse, which has astronomers and other highly educated people quite worried. Join us in this video as we examine the amazing news of Betelgeuse's imminent destruction as foreseen by the James Webb Space Telescope, and how physicist Michio Kaku explains how this new development will affect our cosmos and our existence on Earth. Betelgeuse is a massive marvel that has long captivated cosmologists. It was first discovered by a Greek astronomer named Antonius, and because of its size, it can be seen in the night sky from Earth, especially during the winter. If you're interested in cosmology, you've probably seen or heard of the star, which is reddish-orange and marks the upper left shoulder of the Orion constellation. As you can see, this star is ancient and may be one of the brightest stars in the night sky, but one of its great qualities is that its brightness fluctuates. Let's examine some of the star's unique characteristics. The majority of the stars in the night sky are far from Earth. The closest star is 4.2 light years away. If you don't understand how the term light years conveys distance, think about moving at the speed of light for an entire year. It has been demonstrated that light can travel 186,000 meters per second, so the distance light can cover in a year is equivalent to 1 light a year. If you calculate the distance, you'll find that it is billions of miles. However, some stars are much farther away, and Betelgeuse is one of them. Since Betelgeuse is located roughly 600 light years from Earth, even if you would have traveled there at the speed of light, it would still take 600 years. This is because even our fastest space rockets cannot move that fast, but this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so bright despite its distance, it's because of its special characteristics like size and luminosity. The radius of Betelgeuse is thought to be about 1,000 times that of the Sun, making it many times larger than the Sun. Unfortunately, Betelgeuse appears as a disk in space when viewed through modern telescopes, while different stars appear as tiny points of light. This is believed to be due to reactions at the outer layers of its atmosphere. In terms of mass, Betelgeuse weighs between 12 and 19 solar masses. A solar mass is a standard unit of mass used by astronomers. One solar mass is equivalent to 2 by 10 to the power of 30 kilograms. Since there are no other planetary bodies orbiting it with which to compare it, and we are obviously unable to measure it directly from Earth, Betelgeuse is at least 12 times heavier than our Sun. The brightness of Betelgeuse fluctuates between magnitudes +0 and +1.6. To put it simply, Betelgeuse is many times more luminous than our Sun, which is why it was given the moniker Red Giant. However, this fluctuation is caused by its pulses. As Betelgeuse expands, it becomes brighter. When it contracts, this cycle can last anywhere from 10 to 100 days or even longer. One of Betelgeuse's unique characteristics is that its surface is covered in dark magnetic spots. The magnetic field is much stronger here than at the typical surface, but the drawback is that these strong magnetic spots obstruct the flow of hot gas to the star's outer surface, making the star cooler in these areas. The reason Betelgeuse is colder than our Sun despite its size and brightness is explained by the fact that it contains a lot more of these spots than our Sun. To give you an idea, although the Sun also has its own black magnetic patches, the ones on Betelgeuse are somewhat bigger and more numerous. Additionally, Betelgeuse has a magnetic field 10 times stronger than the Sun's, which explains why the gases on its outer layers seem to be in circles or curves when seen via a telescope. The spots on Betelgeuse may be twice as huge as those on Earth. The surface temperature of Betelgeuse is around 3,500 K. This low temperature adds to the star's feeble energy and distinctive red. Around 10 million years ago, hue Betelgeuse was yellowish, similar to our Sun. Over time, the color changed to orange-red, and then about 100,000 years ago, it gradually began to change into the red star that it is today. This fact has led scientists to believe that the star is maturing. If Betelgeuse hadn't been so far away, it would have been a fierce competitor to our Sun, producing up to 100,000 times more energy than the Sun. It's quite remarkable that at night we could still see Betelgeuse, which is 600 light-years away. Our Sun is only 8.3 light-minutes from Earth, which explains why it's so powerful. If Betelgeuse were just a little bit closer, we could also see it during the day, but if it were to replace the Sun, it would consume or displace Earth and the other 4 planets nearby due to its enormous size, and even if it were to match the Sun in size, it would still emit more radiation. Located in the constellation Orion, approximately 600 light-years from Earth, Betelgeuse, also known as Betelgeuse, is a very giant star. One of its most remarkable features is its enormous size. It has a radius several times greater than that of our Sun and could easily encircle Jupiter's orbit if it were positioned at the center of our solar system. Because of its legendary size, Betelgeuse appears as a disk rather than a point of light when viewed through powerful telescopes. Unlike most other stars, despite their size, Betelgeuse isn't the biggest star. Its mass varies between around 12 and 19 times that of the Sun. This discrepancy in mass estimations results from the difficulty of accurately determining the mass of stars that do not have partner stars or other objects to serve as gravitational reference points. Even at lower estimated masses, Betelgeuse is still a massive celestial body, and one of its other essential qualities is its brilliance. Its brightness varies steadily over time, ranging from magnitude 0 to plus 1.6. At its brightest, a magnitude 0 star is around 2.5 times brighter than a magnitude plus 1 star. The brightness of Betelgeuse may surpass that of the Sun by up to 1,000 times. This variation results from the star's internal processes, which produce its pulsations, intermittent expansions and contractions. When Betelgeuse expands, it gets brighter, and when it contracts, it dims. These pulsations may continue for months, giving the star a more dynamic look in the night sky. Because of its relatively low surface temperature, roughly 3,500 Kelvin, Betelgeuses have a pronounced red hue that is characteristic of red giant stars. Stars nearing the end of their life cycles, such as other red giants, are in the late stages of stellar evolution. Dew has started fusing heavier elements after depleting the hydrogen fuel in its core. This process creates energy and causes the star to expand outward, and its atmosphere is full of intricate physical phenomena. It exhibits dark magnetic patches on its surface. When the magnetic field is higher in the surrounding areas, these patches stop heat from convecting, resulting in colder patches on the surface. Although Betelgeuse is still a huge active star, it will someday explode as a stunning supernova. Betelgeuse is a massive star that is nearing the end of its life. When it runs out of fuel, it will go through a drastic process of fusion that turns heavier elements like carbon and helium. This will cause the star to expand to possibly much greater size, making it one of the largest stars in the night sky before dying in a catastrophic blast known as a cosmic explosion, which is the death of a massive star. A supernova strength is sufficient to momentarily eclipse a whole galaxy. This phenomena may cause shock waves that travel across space, and it's feasible as Betelgeuse nears the end of its stellar life. Astronomers are closely monitoring its behavior in hopes of learning more about the future of stars and the evolution of the universe. The star is expected to eventually go supernova, an explosive event that will result in the ejection of its outer layers into space, leaving behind a dense core that, depending on its mass, could collapse further into a black hole or become a neutron star. A supernova is a cataclysmic event in a star's life cycle that signals the end of its evolution. Given its extreme brightness and close proximity, Betelgeuse's eventual supernova could be seen from Earth without the use of a telescope. This explosion would release enormous amounts of energy, producing heavy elements like iron and nickel that are necessary for the formation of planets and other celestial bodies. These elements would be dispersed throughout the universe, enriching the interstellar medium and helping to create future generations of stars and planets. It's interesting to note that in recent years, scientists have been able to detect strange variations in Betelgeuse's brightness, which has led to speculation that the star may be on the verge of exploding. However, it's difficult to predict with precision when the star will explode. Some researchers have suggested that Betelgeuse could go supernova within the next 100,000 years, which is a short time in the universe's life, but it's still too far away to pinpoint. The James Webb Space Telescope has given scientists new insights into the behavior of the stars. Its red capabilities enable scientists to study the star's outer layers and magnetic fields in unprecedented detail, and the JWST findings have helped confirm the ongoing changes of the star, including its irregular brightness and potential instability. These discoveries provide important insights into the mechanisms behind a star's demise, improving our comprehension of stellar evolution. The cosmos will be significantly impacted by Betelgeuse's passing. The cycle of star birth and death might be further accelerated by the supernova shock wave, which may cause other stars to develop nearby. In the larger scheme of cosmic evolution, the elements created by the explosion will also disperse across space, helping to create the building blocks of new planets. Even though we won't be around to see the last moments of the star, Betelgeuse's death will not only signal the end of one of the largest stars we can see, but it will also open the way for the next generation of celestial objects. The study of Betelgeuse gives astronomers important insights into the life cycles of stars and the dynamic nature of the universe through the use of advanced technologies and space observatories. Scientists hope to continue studying Betelgeuse in the future and gain a better understanding of the processes governing the birth, life, and death of other stars with similar characteristics. Our knowledge of astrophysics will be further shaped by the data acquired from the star, which will enable us to solve the puzzles of how stars change over time and the implications of their explosive deaths for the cosmos as a massive and dynamic star. Betelgeuse is a crucial component of the cosmic puzzle, and its eventual demise will be one of the most fascinating events in the history of our galaxy. However, it's important to keep in mind that the universe is always changing and evolving, with new stars being born all the time. The energy released by supernovas like Betelgeuse will ensure that the cycle of life and death in the cosmos continues. Betelgeuse's legacy will endure not only in the elements it produces, but also in the knowledge it has imparted to generations of astronomers and stargazers. By studying these celestial giants, we are reminded of the vastness and complexity of space, as well as the astounding processes that shape the universe we live in.